Installing CRI-O is easy. It's available on most of the Linux distributions, and similar to Podman, it does rely heavily on Linux to work. CRI-O is not a container runtime. Instead, it uses OC-compliant container runtimes, default one being runc. Once you have both CRI-O and CRI-O tools installed, you need to start the CRI-O daemon. Unlike Podman, CRI-O requires a daemon to work, similar to Docker. You can start it with systemctl start CRI-O. To talk to CRI-O, you need CRI-CTL, which, confusingly, is not part of CRI-O and instead a general CLI to talk to CRI-enabled runtimes, including CRI-O. Even though it's confusing, it only shows that all of these standards and interfaces allow a lot of intercompatibility between different tools. While CRI-O supports rootless containers to some extent, you need to keep in mind that it's meant to be a container manager for Kubernetes nodes. On Kubernetes node, you don't have many users, and the only job of the node is to run containers. So while you can run CRI-O as a different user, in production environments it would most likely be run under root, at least for now. CRI-O is not capable of building images, but it can pull them. It cannot push because it's not the CRI-O job. CRI-O also uses the same location for container images as Podman and Builder, so images built by those tools will be available to CRI-O. And because those images and CRI-O are following OC standards, there should be no compatibility issues. Let's pull our image. CRI-O, of course, has a concept of pods because it is meant to be a container manager for Kubernetes. But unlike Podman, pods are not something optional. You have to create a pod because that's the smallest deployable unit in Kubernetes world. To create a pod, you need a pod definition in either JSON or YAML format. And in addition, we also need a container definition. Then to create the pod, we need to run CRI-CTL runp pod.yaml. The newly created pod is visible if you run CRI-CTL pods -o table. Now we need to create a container inside this pod by running CRI-CTL create, the pod name, container YAML and the pod YAML. And we also need to start the container. CRI-CTL start container ready. Finally, we have a running container with CRI-O. We can exec into this container, check its logs, and do all the other things we would expect from a minimal container manager. Unlike Podman though, CRI-O is not meant to be used by humans directly. It's a purpose-built container manager for Kubernetes, and that's where it should be used. It is stable enough to be the default container manager in OpenShift, one of the most popular and widely used Kubernetes distributions. If you look under the hood of any up-to-date OpenShift cluster, you won't find a sign of Docker. It's all CRI-O working over Kubernetes runtime interface. But there is more here that we should briefly discuss.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.